the roots are dependent on the delta value, right? And what do we consider? We consider three things. Well, the first thing is oh, mama, that's the wrong way. The first thing is this thing over here. Okay, so we're going to consider three cases. The first case is where the roots are the delta value is equal to 0, right? The delta value over here is less than 0, and then the delta value over here is greater than 0. Now this means that delta is positive. This means that delta is negative. And don't forget what delta stands for. Delta stands for b squared minus 4 times a times c. And what we are interested is in the root of that. We're interested in the root or the square root of delta, right? And everything depends on the delta value. So delta could be equal to 0, delta could be negative, or delta could be positive. And what does each of these conditions tell us? Well, if delta is negative, if delta is equal to 0, then the roots will be equal. We've seen this before. And it will also be rational. That's very important. It will be rational. If delta is negative, we say that this number is imaginary. The root is imaginary. And we've already seen what this means. It does not touch, let's say, no x-intercepts for those curves. Okay, and therefore it's imaginary. And then it could be positive. Now it could be positive, but it depends on two things, and I'm going to break this up into two categories, and we've seen this before as well. If delta is the root of a perfect square, in other words, delta is a perfect square, like we've seen in video 9, I think, or 8. Then we say that the root is going to be rational. It's a real number, and it's going to be, this is rational, and of course it's a real number. And this over here, it's going to be real, but also rational, if it's a perfect square. If it is the root of not a perfect square, then this will be a real number, but irrational. Okay, and so now I'm going to give you the exercises to work through this in the next section, where you'll get about 10 questions that you need to look at. And that's it. That's how you determine roots. You just substitute things into this delta, put it in b squared minus 4 times a times c, and then you determine if delta is 0, you know that there's going to be a root where it's going to be graphically on the turning point on the x-axis. If it's negative, it's going to have imaginary roots with nothing touching the x-axis. And if it's positive, it could either have rational roots or irrational roots, and that depends on whether the delta is a perfect square or not a perfect square. Okay, well done. That concludes the section on the nature of roots.